Welcome to another coding tutorial, and in today's video, I'm going to show you how to make spiral Betty. This tutorial is actually a suggestion from one of you guys, so if you would like to suggest an idea, you can fill up the form on my website, which I will link in the description below, and maybe you might see your idea in the upcoming video. So what is spiral Betty? Spiral Betty is a technique where you convert an image into a spiral pattern, where the brightness of the image controls the thickness of the spiral lines. The type of spiral that we're going to work with is called an Archimedean spiral, and it is named after a 3rd century BC Greek mathematician Archimedes. This type of spiral has a key characteristic where the distance between each loop is the same, and it can be described by an equation r equals to k times angle, where r is the radius and k is a constant that represents the distance between each loop. So let's start by creating a spiral pattern. We're going to start by writing a for loop that goes from r equals to 0 to r less than, how about 100, and then r plus plus. And r is for radius, and the key is that this radius is going to be incrementing at a constant pace, in this case 1. And to actually draw on the sketch, we need to convert from polar coordinates in terms of r and angle to a Cartesian coordinates in terms of x and y. So we're going to use an equation x equals to r times cosine of angle, and y equals to r times sine of angle. And we also want to declare what angle is, and we're going to set it at 0 initially before the for loop. And then inside here, we're going to draw it out in a shape of an ellipse, which takes in a total of 4 arguments. The first 2 are the x and y coordinate of the center of the circle, and then the 3rd and the 4th are the size. I'm going to set it at 3. Let's click run. All right, so now, as you can see, it's at the top left corner here, and that is because the initial value is at 0, 0, or the origin. So we want to move that center of the circle. I'm going to declare 2 more variables. Let's call it cx and cy for center x and center y, and calculate it as width divided by 2 and height divided by 2. And all we want to do is that we want to add it to our x and y equation here. Alright, so now it's moved to the center of the sketch, but as you can see, the radius changes from 0 to 100, but the angle we have not incremented, so we just get a line. So we also want to increment the angle inside this for loop by, how about just by 1. Alright, so now we get a shape of an Archimedean spiral. Let's play around with some of these variables to see if we can manipulate the shape into something different. Let's start with, how about this number here, 100. What if we change this to 200? Now we get the bigger size spiral. So if we change the increment here to something smaller, let's do 0.1. We get something more dense. What if we increment the angle at a smaller pace? Alright, how about we put all of these hard-coded numbers into variables? So let's start with angle increment 0.1, and then 200 here. Let's call that radius max, and then let's call this radius increment. And let's put radius increment at 0.01 and angle increment to be much smaller at 0.005. And it is running kind of slow right now, and that is because I put everything in the draw loop, and it's basically drawing the same thing over and over again. So actually inside setup, I'm going to put in no loop, and no loop basically just allows us to call the draw function just once. Now that we have a spiral shape, let's convert an image into a spiral pattern. First, we're going to come to this arrow here. We're going to click the plus sign and then upload file. And then this is where you're going to drag and drop your image file into. Once your file is uploaded, what you want to do is that you want to preload your file onto the sketch, and you can do that by first, let's create a variable called img for image, and then you want to call a function called preload. And then inside here, you're going to set your variable img to another function called load image. And then inside the load image function, you want to put where the image is. And in my case, it is over here with the name pat.png because it is a picture of myself. All right, let's click run just to make sure everything is running properly. All right, so inside draw here, we can use the function called image and then put in 3 arguments. The first one is the name of the image file, in our case img. Then the second and the third are the x and y coordinate of where you want to place the top left corner of the image. So 0, 0. All right, the image size is a little bit bigger than the size of the canvas, so I want to resize the file, and you can do that by coming to setup here and put in the name of your file, the word resize, and then let's just resize it very small. So let's do 200 by 200. So as you can see here, now the image is resized to that particular size. So these 2 arguments are the desired new width and height of the size of the image, right? But if let's say you don't know what should be the proportional height of the new size, what you can do is actually you can put in number 0 here as the second argument, and it will still proportionately resize your image. And actually, instead of 200 here, we actually want to resize it to be the size of the width and the height of the canvas. All right. And actually, I do not need to display the image. So next, what we want to do is that to get the spiral Betty pattern, you want to get the brightness of the image and then use that to control the thickness of this spiral pattern. So what we can do is inside this for loop here, we can use a function called get. So first, we're going to create a variable called pixel value, set it to img.get, and this function get, providing x and y coordinate, will get the color value of that specific pixel. So let me just print out what pixel value is. So as you can see here, these are the 4 RGBA values of the image. But to actually get the brightness value, what we can do is that we can just put in another function called brightness and put in as an argument the color information, so brightness of pixel value. And now instead of those RGBA values, we get the brightness value of all of the pixels that ranges between 0 and 100. We want to set the thickness of the stroke weight of the ellipse based on the brightness of the image. So I'm going to actually declare a variable called SW for stroke weight and set it equals to brightness of pixel val. But that would be way too big, right? Because the value ranges between 0 and 100. So we want to map this value between 0 and 100. And actually, I'm going to set it to stroke weight between 1 and 5. Then we don't need to print this out anymore. And then here, we're going to set stroke weight to be SW. All right, how about we change some of the variables here? How about we do radius increment to 0.01? Ooh, maybe just 0.05. Oh no, we need to go 0.005. All right, so you can kind of see the picture underneath. And I actually, instead of doing between 0 to 100, I want to flip it. So between 100 to 0, meaning that the brighter the image, the thinner the stroke weight. All right, and I'm going to change this back to 0.01. Okay, that looks pretty good. So that is the baseline of how we can create the spiral Betty pattern. Next, we're going to create a graphical user interface, or GUI, which are things like sliders and color pickers, so that we can change a lot of these variables easier on the sketch. So let's start by creating one slider. Let's call it radius max slider. And before I move forward, I want to actually comment this as image variables, and then how about this one as GUI variables. So inside setup here, we're going to create a slider by setting this new variable to a built-in function called create slider, and this function can take in up to 4 arguments. The first two, let's do 0 to 100. These are the range of the slider. So let's click run. All right, as you can see here, we have a slider, but it doesn't do anything just yet, right? So we can actually put in the third and the fourth argument. The third argument is the initial value that you want that slider to have, and the fourth argument is the incrementing step. So how about we put in initial value as 10 and then incremental step as also 10. And this is at 10, and as you can see here, it's moving at a 10 increment. So to get the value that we can actually use, we want to come to the draw function here, and we want to call a function value. So radius max slider dot value, and if I click run, and it is at 10, right? It starts at 10, but as I move, it doesn't actually move with me, or it doesn't print anything, and that is because we have this no loop function. So let's comment this out. 10, 20, 30, 50, 70. All right. A few other methods that we want to call. The first one is that we want to, how about, set the position of this slider to be on the right of the canvas. So now it's here. And then I want to also set the size to be 80. All right. And as you can see here, the draw loop is being called over and over again, and that is why we wanted to call the no loop function so that we don't have to call the draw function over and over again. So what we want to do to actually solve this issue is that what if we just call whatever is inside the draw function right now only if the slider is moved. So we can do that actually by using a function called input. So radius max slider dot input. And then inside here, the argument that we want to put inside here is actually the function that we're going to call. So instead of putting everything in the draw function, we're actually not going to use the draw function at all, but we're going to change this draw function to, how about we call it an update canvas. And this update canvas function is only going to be called when a slider is moved. So now we put in update canvas here. Click run. You don't see anything at all, but as I move the slider, now the image appears, right? So we also want to, we can delete this no loop. We want to actually call update canvas initially inside setup. So even before we move the slider, it is going to be called once. Oops. Reading value. Let's just comment this out. The reason that happens is because I put update canvas before all of this, and the value of this slider is not initialized yet. All right, so we can actually just delete this. Before we move on to the next slider, how about we put this in a separate function, which I'm actually going to just call GUI. And the reason I want to do this is that there are going to be a bunch of different things as part of this graphical user interface. So I want it to be cleaner. So let's just put all of this inside here and then just call GUI up here. All right. And before we move on to the next slider, I also want to set x0 to be equals to width plus 10. So it is going to be the value of where I placed the slider here, and then y0 will be 10. All right, so let's go to the next variable. The next one that I want to create is a slider for the angle increment. So let angle increment slider be a new variable, and we basically want to do the same thing here, but change from that name to this name. And we want to move it down by, no, x is the same. Let's move y down by 30. All right. And then inside update canvas here. Oh, the key thing I didn't do yet is that right now, actually, the slider doesn't have anything to do with the image itself. So now how about we set radius max to be equals to radius max slider dot value. Oops. Let's do GUI before update canvas here. Okay, and there you go. And we want to actually set, how about we change this range to 0 to 300 and have it start at 200. All right. Okay. And then the next one is going to be angle increment equals to angle increment slider dot value. And it is going to change this step here, right? But before I click run, we also want to change these values here. I want to change it to be much smaller. So between 0.001 to 0.01, I want to start it at 0.005 and increment it by 0.001. Click run. Nice. The next one that I want to do is actually I want to change the color of the image here as well as the background. So we can actually use another built-in function called create color picker. So let's see how we do that. First, let's create a variable called, how about img color picker. And then inside here, we're going to set img color picker to a function called create color picker. And we want to, how about we start it at as a color red. All right, let's click run. All right, so we have this color picker here with an initial color as red. And as you can see here, we can just change the color as we wish. Now, we can change the position and size the same way that we do here. And we want to call it only when we click the color itself. So by using this input method as well. So now let's change all of these. And we're going to put it below here. Click run. Okay, and now inside update canvas, we also want to set its value to something, right? So we actually want to set it to image color. So image color picker dot value, and then how about we do fill img color, and also stroke img color. There you go, it's red. All Right, so now we can just change the color, just like that. Then the last piece is going to be the background color, which we're just gonna copy and paste this. And do not forget to create a new variable. Let's call it bg color picker. And bg color picker, let's start it at what color? Actually, let's just do this gray color here. Move it down by another 30 and update all of these variable names. Click run. Okay, and then down here we also want to set bg color to be equals to bg color picker dot value, and we actually want to move this background function to be here, right? Because if not, then we declare the color afterwards. All right, so now we just put in bg color here, click run, change the background color, change the image color. Perfect. And then now we have this to change the angle increment, and then this to change the maximum radius. All right, before we move on to the next step, let's label these color pickers and sliders. So we can do that by using a method called createDiv. So we're going to come here. I'm going to set a variable, let's call it radius max label, to a function called createDiv, and we're going to put what is the label that we want. So we're going to put in max radius, and then basically we just want to set its position, right? And we can do it the same way. So position, and I want it to be to the right of this slider. So let's do x0 plus 100, same position, so y0. Nice. And I'm going to do the same thing for all of these.
A few moments later.
Ta-da! All right, so now that we have this, the last step that we want to do is that we want to be able to save the image so that you can do whatever you want with it, whether it to be printed, laser cut it, whatever you wish to do. We're going to start by creating a drop-down list using a function called createSelect, which the options that we want to create is the different types of file that we want to save. So PNG, JPEG, and SVG. So come up here, let's do file type selector, and then inside here, we're going to do file type selector equals to create select. Click run. All right, so now we have this drop-down list, but it has nothing inside yet. So let's start by creating position and size. So we're gonna put it just below here. So let's do 130 and same size. Okay, it still has nothing inside. So what we can do is that we can put in file type selector and options. And then we're gonna put in PNG, oops, option. All right, option. So we just have one option, but we want 3, so let's do 1 for JPEG and then 1 for SVG. All right, and it starts at PNG, which might be what you want, but you can also put in another method called, I think, selected, and let's say you want it to start at JPEG. So this is going to be the initial value of the selected option. All right, so the last GUI that we're going to create is called Save button, and it is doing exactly what the name suggests. It is going to allow us to, once clicked, it's going to save whatever file that you want. So inside here, we're gonna set save button to be equals to create button. Click run. The button is down here. Inside here, you actually want to put in what is going to be the label for your button. So let's do save image. All right, and we're gonna position it right next to here. So it's gonna be x0 plus 100. And let's not set the size here. Okay, so right now when we click the button, it doesn't do anything yet. So what we want it to do is that we want it to save the image. But here's the tricky part. With the JPEG or the PNG file, we can save image easily using the save function. So before we go there, let's see how we can do that. So we want it to activate this button when the mouse is pressed. So we're going to do save button dot mouse pressed. And then inside here, we're gonna write a function, but instead of writing a separate function, I'm going to use the new syntax where we can just write a function inside here. So what we can do is that we're gonna put in a parentheses, equals, more than sign, and then a curly bracket. And then this basically says that when the mouse is pressed, we're gonna call this function. And this function, what it does is that if the file type selector dot value, actually there's no parentheses here. So if file type selector dot value, so if this value inside here is not equals to SVG, then we can just save the image using the function save canvas. And the arguments that we want to put inside here is the name of the file that we want to save. So how about we do img, and then the second argument will be whatever the file type it is, right? Either JPEG or PNG. So file type selector dot value, but we actually also want it to be a lowercase. We just add another method called to lowercase, and this allows us to save it as a lowercase name. Let's just do else, and then we can just print what? Print SVG file. So it will come to else only if the selector here is an SVG. So if it's JPEG or PNG, it should just save the image. All right, let's click run. Now, how about we change the color to black, and let's do the background to maybe light purple. Okay. Oh, it's a bit slow. Okay. And then now set it to PNG, save image. All right, so the image is saved. But let's say that I change this to SVG and then I click save image. And you can see here, it's being printed that, hey, it is not PNG or JPEG, it is SVG. And the reason that we need to do it separately is because the rendering mode for SVG versus JPEG and PNG are different. Instead of just printing out SVG file here, what we want to do is that we want to update the update canvas function such that it can deal with a new rendering mode every time the SVG option is picked. So we're going to come back to update canvas, which is down here actually. And then I'm going to actually come up here first and set another variable. Let's call it renderer. And then down here, we're gonna set a variable called file type. And if file type, actually file type is what? It is going to be file type selector dot value. And if file type is equals to SVG, then we want to set the render mode to SVG, and else we're going to set it to P2D, which is a 2D mode. So usually inside here, inside the canvas, create canvas function here, if we don't put in anything, it is actually in the P2D mode. If you have watched some of my other tutorials, we have worked with the WebGL mode as well. So the third argument is where we can input in a different rendering mode. But instead of actually changing the mode in this create canvas here, we're gonna create a new graphics, which is basically a new canvas. That is not the canvas that you see here. So inside update canvas here, I'm going to actually create a different graphics, a different canvas called graphics, set it to create graphics method, and set the width and height to be the same width and height of this canvas that we see. And then the third argument, it's gonna be renderer. Now let's click run. Get an error. For graphics, I was expecting P2D for the third parameter. Oh, renderer. Okay, first I'm going to call image and put in graphics 0,0. And this function allows us to draw the graphics on top of the canvas here. And the reason that we want to do this, as I mentioned earlier, is because we want to be able to swap out the rendering mode every time we switch between JPEG or PNG versus SVG, right? But now all of these functions, background, fill, stroke, and stroke weight, are being called as part of the canvas. So to call it on this graphics, this new graphics, we also need to do graphics dot background, and we need to do that for fill, stroke, and stroke weight, and also ellipse. So for all of them. So basically we're calling all of these functions on the new graphics image, right? So let's click run. And you don't see anything different. But now, let's say that we change it to SVG. We click save image. And we put in update canvas here when we save as SVG. Let's click run again, and then change to SVG, and then save image. You get a bunch of errors, and it just said SVG is not defined. And that is because we're missing the library that we need to work with an SVG file. So all we need to do is we need to come to this arrow here, click the index file, and then we want to actually link in an extra source file here. So this is the package that we need. And when I was just copying this line of code into my previous index file, I got an error. So I would recommend that you just copy and paste this entire index.html file from my code to your file if you encounter the same error. Now let's click run. And there you go. Now what we want to do is we just want to save the image as the SVG file. We can just put in graphics.save and then the name, which is going to be img.svg, right? Click run. And if it's as JPEG save, everything is fine. PNG save, everything is fine. And then SVG save. Graphics is not defined, so maybe I need to do let graphics as a global variable, and then change this. Let's try that. SVG and then save image. All right, so, and why do we want to save it as an SVG? So as you can see here, as I increase the size of my image, the resolution is still intact. And that is the beauty of an SVG file that allows us to scale up and down the image file without losing the resolution. All right, so that's it for this video, and I would love to see if you do actually make something physical with this spiral Betty tool. So give this one a try.